Somebody else is coming. Okay. Anyway, let's start. Just a few words about us. We are working. We have been working for 15 years on average. 25 for me, 5 for him, and 15 for 10 or 15 for Luca. We have been working for an Italian company. You can understand I'm Italian from my British accent. Our company works mainly for big banks and insurance companies. We work for the largest banking companies in Italy. And usually, we are on the bleeding edge of the architecture and the technology. That's why we are dealing with continuous delivery in banks, because usually banks in Italy are not so used to adopt innovation, particularly in production. What's happening in these days is that 2 or 3 large banks asked us to introduce continuous delivery up to production in very large systems. Okay, so man walk on moon. It's great news. That's nothing new. Continuous delivery is no news. I mean, how many of you are working with continuous delivery in your everyday work? Okay, many. Okay. And how many of you are working with continuous delivery with databases and no downtime? 1, 2, 3, 4, 5. Okay, that's not so. Nothing new. Okay. Achieving continuous delivery with 0 downtime means you have to adopt some principles. You have to modify your application lifecycle. You have to adopt some patterns, and you have to adopt some tools. We will show you about 2 scenarios. One that we call simple, that is a single application with a dedicated database. That's a scenario that's affordable. And then we will show you one of the most complex scenarios we have to face when we have multiple applications sharing a single database. Many of you will think that this is an anti-pattern, but the point is that if you are migrating from monoliths to microservices, at one point in time, you will find out that you have multiple applications sharing only a database. And that's the worst scenario you can face while dealing with 0 downtime needs. Okay? So let's start with a single application with a dedicated database. We have some principles to follow to get 0 downtime. The most important one is to avoid breaking database changes. This means that you have to apply the changes to your database in a way that ensures that you maintain backward compatibility, because your application is running and it has to run with the old schema, with the old DDLs, and with the new schema. And you can go back and forth without any downtime. To achieve this, you have also to treat your database as code. This is no new. I mean, you have to do some versioning, and you have to manage its life cycle. And what you have to do, last but not least, is to automate DB testing. I mean, I cannot achieve 0 downtime or continuous delivery without efforts on automated testing. To treat database as code, you have to choose a way to represent your change sets on database. You have different tools with different approaches. You can go from plain SQL, or you can have an XML description of your change set to apply on the database. For instance, plain SQL, if you have Flyway DB, you can use plain SQL. And if you have other tools like Liquibase, you have XML. Other tools have JSON or other representation of the chain sets. No matter, you have to put in place a way to have your database described and versioned like your code. Which are the objects you have to version? Usually the data description language, DDL. You have to put some data. We will see which kind of data you have to put in order to have a good versioning of your database. And you have to take into account that sometimes you have some logic in the database. So you will have to version store procedures. What you have to do, you have to version control both code and database. In a way, you can relate the application code and the database via version numbers and explicit dependencies. You have many people that are talking about these kind of things. You can find an interesting link at the end of this slide. Okay. Okay, with a dedicated database for the life cycle, you have a single project for database and code. Your database code, DDL and logic, and the application share the same life cycle. You put in production a new version of the application. You put in production a new version of the database, more or less, back and forth. Okay. Here is depicted a pipeline. You have Maven for building your code and your SQL. You put it inside Git. Jenkins takes care of everything and deploys your Java code. Flyway takes care, or another tool takes care of the database, and they both deploy your things, and things are running. You have one team, usually, one project, one repository, one pipeline, and just one deploy. This is nothing different from a normal deployment pipeline. You just add a new kind of tool that takes care of the database updates back and forth. Okay. You have also to adopt some patterns to achieve zero downtime. Who knows about these patterns? Okay, 2, 3 people. Okay, perfect. Okay, basically, there are 3 patterns that are fundamental to achieve zero downtime. One is expand and contract. The other is blue-green deployment, or feature toggle. You can use one or the other, depending on what you prefer. Of course, you will have to adopt delivery pipelines. Okay, let's see expand and contract. To achieve zero downtime, you never have your application to fail when accessing the database. This is the worst kind of change you can do to a database, and we have used this as an example. That's renaming a column. If you rename a column, your application will stop working because if you keep the last version, this will access the column that's no more existent. Okay. So how do you apply expand and contract to rename a column in order to have a zero downtime application of this kind of modification to the database? We have basically 3 phases: expand, transition, and contract. In the first phase, we are renaming surname to last name. We add a column that's last name. And we add some logic in the application in order to have the same data on the two columns. You can choose. You put some logic in your application that's copying the data even in last name, or you add some trigger or logic for data alignment in the database. It's up to you. Then you have a transition phase where you adapt application logic to use the new column. So at this point in time, the application is still using surname. Then, with the data aligned, you modify the application using last name instead of surname. Of course, you have to test extensively that no part of the application is still using surname. And then, third phase, contract, you drop the surname column. Okay? In this way, you ensure that your old version of the application can work with your new database, and your new version of the application will work with the new database with no downtime. Same application, no downtime, modification applied. Okay? Okay. Of course, if you have to achieve zero downtime, you cannot have only one version of the application at a time. So the old version is usually hidden by a proxy. You use the old version, you put in place even the new version of the application, and you just switch instantly with a proxy. Okay. So by using blue-green deploy and expand and contract, you achieve, in almost any case, zero downtime. Okay. Another way to have the same feature as blue-green deploy is to insert in your code a feature toggle. That's a toggle that instructs your code to use the old version of the SQL or the new version. Oops, the new or the old. Okay? And you can toggle which column you are using at runtime. So by using a toggle at runtime, you can get the same effect as a blue-green deploy. Okay? So these patterns are usually an alternative. Okay. This is an example of a zero downtime blue-green and expand and contract deployment with a new version of the database. You have the old version of the application that's in place, accessing the surname column. Then you expand and add the last name. You put in place version 2.0 that's using only last name. And you update version 1.1 that's accessing surname and last name, keeping them aligned. Okay. You have a transition phase where if you use blue-green deployment, you can have some requests served by the new application just for testing purposes. Just imagine you instruct your proxy to test some requests from people coming from a certain country to the new application with no downtime. And when you have tested, you can contract and put out of production your other application and remove the column. Okay? Okay. The third ingredient for zero downtime are some tools. You need some database automation tools. For example, Liquibase or Flyway are common tools for people coming from Java world. And you have to use some continuous integration or delivery tools such as Jenkins or other tools for having a delivery pipeline that helps you in delivering everything instantly. Okay? No matter the tools, there are many tools. You can even imagine to use tools coming from other languages. We are Java guys, but we could imagine even to use active migration coming from from Rails and from Ruby world, and it would be not a problem. I mean, Rails is applying changes to the database, and we are applying changes to our Java code. 2 life cycles, 2 languages, no problem. You can use whatever kind of tool you want. Okay, tools are required, but are not enough. Even in the simple case, there are some open points. The first open point is that migration can fail. Principles, patterns, and tools mitigate the problems, but keep in mind that when you have to deal with databases, you can have some state on the database, particularly in some databases where you do integration testing. You can have some data coming from production, for instance. That's not the same you're using in testing your migrations. So you can find that sometimes your migrations, your automated migrations can fail. And you have to plan for some sort of automated database rollbacks. The tools are not helping you in any way. You have to put in place some rollbacks by using database-specific ways to achieve rollbacks. Some databases have the ability to tell, okay, snapshot and then rollback whatever I did, DDLs or DMLs or everything else. Or if you want, you can go low level and use ZFS and snapshot, but you have to take into account that this is a problem you have to manage. The other open point dealing with huge software and huge data is that you have to choose carefully what you have to put in your version control system regarding data. It's okay to put DDLs, it's okay to put store procedures and logic, of course, provided that backward compatibility is guaranteed. I mean, I cannot put a new version of store procedures that breaks the compatibility with the application that's running. Regarding the data, you have a warning. You have to divide the data in 2 big categories. Static or domain data, and live and business data. Live and business data is data that's coming usually from production, eventually masked, that's able to tell you that your application is working in an integration environment. Some tools are advising to put the database, the development database, to put data coming from production. Don't do that. Put in your development database just the smallest amount of data you can handle to have some unit tests running. Because if you put live or business data in your version control system, you end up with a mess with huge amount of data, and you risk to break privacy, to have privacy issues, or to need to manage too many things, and you don't have any real advantage. Okay?
Okay. So that was basically the simple or not so simple scenario with one application, one single application with a dedicated database. We saw that, in our opinion, this is the simple one because you have one application, one development team, and one delivery pipeline. So this simplifies dramatically how you handle all of these complexities. In more complex scenarios, you have multiple applications with shared databases. And while this would be normally considered as an anti-pattern, because you normally would have a dedicated database, unfortunately, nowadays, this is not the case. Because monolith to microservices migrations are actually happening right now. And if you do transitioning between monolith and microservices, you usually end up having some sort of situation like this one. You take a monolith, which is a fairly interesting application with its own database. You identify functions, business functions usually. You break them apart from the application standpoint, and you separate code and delivery process of those modules. So you modularize your application on step 2, but those modules share the database. Finally, you slice your database, and those slices of data of the original database go into the new microservice. This is a fairly common way of dealing with those huge and complex migrations. The main problem with this approach is that while you are right in the middle of this transition, you have exactly the most difficult time in your path to deal with database continuous delivery, because there you have multiple applications, multiple application logic with different life cycles and different versioning that share the same database. Okay? And this is inherent to the whole decision of going to microservices, because actually you normally want to go the microservices way because you want to split your functionalities and you want to have those microservices evolve separately. So it's kind of an inherent approach, but yeah, right in between the two easy solutions, you have exactly the most difficult situation for the sake of database migrations, continuous database migrations. While this is a fairly simplified view of a typical monolith microservices roadmap, this is a much more realistic scenario, which is actually taken from a use case from one of our customers. And you usually have to deal, I will not go into the details of each of these steps, but again, the most relevant part here is that for a long amount of time, you will have modules of your applications that somehow begin sharing your database. Okay, until you're perfectly aware that you do not break the whole application logic, and you can split your microservice and your database as well. Okay. Well, we have many issues in a monolith to microservices migration when it comes to database versioning, and the three main concepts here are that you usually have to treat your database not only as code but also as a dependency. I want my application logic to declare explicitly which version of database that application refers to. Because if I have many applications that relate to that version of the database, I can enforce some kind of control over whether applications need to evolve the database or not. And I obviously have to automate and enforce automated database testing. So I want to stress automated database testing, and we will digress a little more on this topic because it is becoming really important to avoid having different applications breaking the database simply because one application decides to remove a column, whereas the others are no longer do need that column. Again, delivery pipelines are crucial, but they become increasingly complex because you have a lot of moving parts, and because you have those parts that interact with each other. So application modules need to interact with each other and with the database. So the release of an application module becomes strictly related to the release of the database. On to the testing. This is nothing new. In testing any kind of application logic, you usually end up having unit tests that test your source code. And you usually have integration, end-to-end testing that stress your application runtime in any kind of integration, acceptance, environment, whatsoever. When databases and database migrations are required, this is not sufficient because you have to take into account also contract tests. Contract tests are not new. They are a pattern of testing that emerged a few years ago, specifically related to microservices, and basically means I am application A and I need to interact with another dependency, say it's a database, say it's a library, whatever. I need to establish a set of tests that on my side actually state what I expect from the integrated piece of software. Say it be it the database or another library from a third party. Okay. Having those contract tests within my environment, within my module, allows me to be always aware that I would not break if I make changes to the database. And I can perform those tests in an acceptance environment, but I can also perform those tests locally on the developer machine or in a sandboxed environment. Sandboxed meaning that it's an environment that is not shared with other modules, other application modules, other application microservices. Okay. But you probably will require a bit more complication. Those contract tests should become part of the tests of your database artifact. Because the database, if your database is the base for application A and application B, you probably want your database to be able to enforce contract tests coming from both application A and application B. Actually, M1 and M2. Module M1 and M2 here. Okay. And this is because database is actually shared between the two. So you have to enforce exactly those rules for both of them. Okay. Again, you can do those contract testing in a local or in a sandbox environment, but you can also do in a acceptance environment and whatever. Okay. Why this scenario is more complex? As you can see, testing strategies become a little bit more complicated. You have many teams that work at different velocities on those application modules, and you have different teams that work on the database. Okay, so you have a lot of moving parts. You have a lot of different delivery pipelines, and you also have a lot of different projects and repositories involved. So you simply can't have a unique Git repository that you can clone and run your Melon test on it, and it's okay. I'm fine. I'm good to go. Okay, you have a lot of moving parts, and probably not all of those moving parts are under the control of the developer. Okay, of the specific developer of, say, module A. What we end up having usually is something a bit more complicated than the traditional pipeline, where we have a continuous integration pipeline for the database, where we can take your SQL logic, you can test locally or test in a sandbox environment, and then you have to version control that integration pipeline, the resulting of your integration pipeline into any kind of artifact manager. This means that you somehow snapshot your database at a specific version, and this becomes the version that any application should declare to use in production. Okay. So it's rather different from the previous approach, because you simply no longer have database and code together. You have artifacts that relate to each other, so the binaries that relate to each other. So when I declare that my application is dependent on database A, version 1.2, then I can enforce the fact that I need exactly that version. And this can be done also by other modules. Then you have a continuous delivery pipeline that takes into account both the database and the applications. Okay, so what we end up having here is that you keep having modules that build, application modules that build your application the usual way, except for the fact that they can integrate again DB and DB testing into their pipeline. And then you finally have to merge all of those application life cycles into the database one. So you have to continuously deliver the database starting from a common pipeline. Okay. On to a bit more technical detail here. We will show you a quick demo. Okay. This demo is basically mimics basically what we have in a normal. Okay, I may fire up the editor a bit. Okay, this demo basically mimics what happens in the normal life cycle of Java applications or whatever applications with the database. So I start with a local development on my machine. I have a project on my machine, which is again a Java project that holds the database. This project, I can show you since we have a bit more time. Yeah, I can make it a bit larger. Okay. Let me see if I can just no. Yeah. Sorry. Ubuntu 18.04 changed a lot in the in the UI, so I think that this is the largest degree of zoom that I can have in. Yeah, okay. The terminal will. I will fire up the terminal in a while. I just wanted to show you the basic structure of versioning database. Okay, this means that I have. Again, it's not that easily readable, but you have a series of SQL statements and scripts to recreate from scratch your database. This is actually how Flyway is working. Again, the tools here are the least important part, but obviously we had to use one to make the demo, so we chose Liquibase for the sake of simplicity, but you can use Liquibase as well or whatever. So here you have your versioning of your database, okay, and each version holds, exactly the code to create your database from zero, from scratch, okay. This is actually an open source database from the Eclipse BERT project. Okay. this project also has testing code. We know it's fairly naive as a code, but the main point here is to stress that within your database module, you can begin enforcing exactly those rules that you want your applications want to be enforced for that database. So for instance, if I want to test that a column is available simply because my applications rely on those columns, I can put a test over here. Are you asking me why shouldn't I make this column mandatory? Because at any time, one application may decide that this column is no longer available, okay, for him and for that application. So that application may decide to just drop that column and has no, and we have no control as to whether this breaks other applications or not. Okay, so enforcing tests on the database project, on the database artifact, it achieves exactly this. Okay. Okay. So, was that okay for the sake of readability? Okay. So, if you launch a basic building process, you can say that we can spin up a new container, a new database container with Docker or whatever containerization engine or orchestration engine you want, and we can see that, okay, we have the tests applied. So what happens in this local build is that you create a new database in a containerized fashion, but again, no matter here. And then you can create exactly all those tables that can contribute to version 1.x of your database. And then you can populate them with test data if you want to. And then you run tests against those DB. Okay? I have 2 tests and both pass. Okay? And this is the local development of the database. Obviously, I need an integration pipeline, a build pipeline, because if I just want to modify a column over here and push this to the source code repository, well, I can break databases for other applications. So I can have a Jenkins pipeline that somehow builds the database. Oops, sorry, logged out. Pretty easy, isn't it?
A secure pipeline.
Okay, it's obviously mostly local. It's a mostly local demo for the sake of, you know, accessibility. Okay. So I can have a pipeline that does nothing more than cloning the repository where I have the SQL and stuff like that, build and test the artifact. The artifact contains all of the SQL migrations that I showed you before, and then publish this artifact to an artifact manager, which, for instance, could be Artifactory, but again, no technologies here are strictly necessary. Okay, so if I can see it correctly, okay, it's version 1.3 snapshot, and I should have the most recent version over, yeah, here. It's 2 hours late because due to the time zone. No, we versioned. Your colleague asked whether we versioned the entire database or SQL. So I imagine you asked whether we versioned the container, in this case, holding the data. No, we actually versioned the SQL code, because that is the way you gain reproducibility. Okay, so those scripts, be it SQL for Flyway or XML for Liquibase, allow you to rebuild your own sandbox environment from scratch. Okay.
The trick is that you should set up some migrations that are able both to build a clean environment or to migrate an existing environment. Because when you get to integration tests, sometimes you take in the integration data from production or pre-production, and you test if the data coming from production is getting you some regressions. So in that way, you are able both to reproduce a certain version from scratch or advance a pre-existing database to a certain version of DDL, more or less. Okay, that's the trick.
Okay. Okay. I have some containers running in my environment for the sake of demonstration. I have a MySQL production environment, so-called production environment, not production really. We can see that in a matter of minutes, or at least seconds. We can also build your database delivery pipeline, which, okay, parameterized. I can fire up a more clearer view of what's happening under the hood. Basically, what this pipeline does is to download the database artifact I just versioned on the artifact manager, creates a sandbox DB, populates this database with the database structure held into the database artifact, optionally set up database test data, and then here you have a complete environment that is ready for integration, testing purposes for all of the applications. And when you arrive here, you're aware that your database hasn't changed in a breaking way, so in a way that breaks the other applications that are running on this database, because the database that was checked out from the artifact manager has undergone a build pipeline where tests were enforced. Okay, so those tests actually allowed me to assess that applications that rely on that database do not break if I make changes to the database. Okay. What happens when I, for instance, make a breaking database change? The breaking database change, sorry, I don't think it's fairly readable. Well, the database change is actually changing the name of a column from customer name to customer second name, which is actually you don't want to do in any environment, as we told before. But for the sake of demonstration purposes, we actually did that, and we versioned that. So, sorry. So I'm acting as a malicious developer that wants to, oh, okay, I can clean verify, and the tests will fail, hopefully. Okay, cool. So those tests are failing, but if I am a malicious user and I want to somehow push this code to the integration environment, I can always commit my code. And push. This was the real one. Okay. Okay. So if I revert back, so what I have here is a far too common situation where a developer makes a breaking change and commits this. Okay, this shouldn't happen because you have tests that prevent you from doing that, but no one prevents the developer from maliciously commenting out this test, okay, in its local environment. Having integration pipelines and delivery pipelines means that you can do this kind of thing. Sorry. You can, again, relaunch your continuous integration pipeline. So the database that takes your source code, compiles your source code for what is related to the database, compiles it, builds it, and tries to push to the artifact repository. This, again, should fail, hopefully. Okay. Test failure. Okay. It's fairly difficult to read here. Okay. Test failure because the original customer name column is not available anymore. So the principle here is fail fast. Okay, so here even if the developer has done some malicious actions, you can be assured that your database changes cannot reach your artifact manager, so cannot be deployed to production or any other lower environment. Okay. 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 Okay.
So what we have seen is that in a simple case, tools are working pretty good, but in a complex case where you have multiple applications sharing one database, the development complexity increases, and you have to govern much more your delivery, because you have to take into account the integration phase with the delivery pipeline, the last failure you have seen, and you have to take into account that you have to introduce some fail-fast rules by introducing contract tests that are a kind of a weird dependency between the database and all of your projects, but they let you ensure that at the unit test level, if you introduce some breaking changes in the common database, you find out that immediately, like in his Maven compilation. So, if you want to put in place, sorry, if you want to put in place a complex scenario, sorry, like the complex one, please remember that you are going to let your developer work much harder, and you have to owe them a free beer before starting digging into this kind of complex scenario. We are going to give you the whole code in a stripped down, simplified way in order to be able to test it at home, complete with Artifactory and the containers. Stay tuned. We will publish the repository on Twitter using the hashtag and the information about this session in the following days. Okay? Okay. Thank you. Any question?
I have a question about this testing phase. Do you only this test only executes these migration scripts from version 1 to version n, or do you also create some more complex tests there?
You also create some more complex tests because you have to take into account that every pipeline, horizontal pipeline, is a huge project. It has end-to-end tests depending on the application logic. So when you get here, you not only run the unit tests on the database, but all the end-to-end tests of all the applications relying on the same database.
Yes, I know, but the question is because let's say this it's renaming of the column is really simple. If you, for example, rename the column that doesn't exist, it's really simple to catch such thing when you execute the script. Yes, but for example, if you modify, let's say, some content of the column, yes, you update the content of the column, for example, to reformat it and replace underscore with dots. Yes, for example, and with if you only execute this migration scripts, then you won't catch such thing because you don't have real data. And the question is, if you execute these scripts only on the schema without the data, or also some base data for testing.
Usually, at this level, you use a schema with real data. But you have to take into account that your migration have to be able both to advance the empty or basic database and the real one. So things get a little bit more complicated. But you called the point. You don't have only to rely on testing your clean data or minimum set of data. These are sort of unit tests. Mm-hmm. When you get to end-to-end testing, you get some data from production or pre-production. You put the data inside the database and you apply the migrations. So you have to have some clever migrations.
Thanks.
Well, and a bit more, if you want to enforce the fact that a specific, let's say, varchar and colon has a specific format, you can write a contract tests that test this beforehand. So it could be a good practice to do so that you can rest assured that application and uses exactly the data it needs, and that column has exactly the format the application needs. Okay. Okay.
The other question: how do you roll back if something fails in production? So do you have a rollback script? Okay. How do you roll back?
Okay. Rollbacks are, as we saw before, yeah. Rollbacks are taken into account in most of the tools that we mentioned here. So, for instance, Liquibase and Flyway allow you to provide some sort of undo scripts, okay, which actually roll back what you tried to do, but for any reason went wrong, within a set of migrations. But migrations in production may fail for a lot of different reasons, okay? Say because you're actually testing different database versions between test and production, which is not always the case you want to test, but unfortunately it happens, okay? And when this happens in production with a huge database of your customers, it's not something you want to experiment for the first time, okay? So migrations can fail for any reason. The main point here is tools can help you, but can help you up to a certain point. you probably have to devise a much more careful rollback strategy that could take into account also database rollbacks that leverage low-level database strategies. My colleague mentioned SQL Server, Snapshots, and Rollbacks feature, which are available in some of the latest versions. This is a fairly useful tool for doing that, but again, it's vendor-specific, so you have to carefully devise your rollback solution because, in our opinion, tools alone, the database automation tools alone, are not always sufficient in this case. Okay.
And usually, it depends on your customer. 90% of the customers prefer to not to automate the latest step. I mean, you give me the migration script and then I execute it manually. So rollback strategies are up to the database manager that's saying, okay, if something goes wrong, I roll back, but I have to take down the application, so some downtime is accepted from some certain point of view. It depends on the organization. So that's an open point. I mean, but you have to take care of this when you put this in production, particularly in the latest step, production or pre-production or environment. You don't want to destroy your data. Because when you have migrations, they can fail in many different ways, unpredictably. I mean, you end the space in the file system. That's the main cause of rollbacks. You have a migration that adds some data, and you end the space. So you cannot completely automate the rollbacks. Okay.
Such contract test?
Actually, no. Well, I showed it rather swiftly. Take it as a very naive kind of code because we just wanted to arrange a non-production grade test because those obviously involve also test and production structures and so on. So we didn't want to bring one of our customers' examples here because we weren't allowed to do that. Okay, so.
But you can create some.
Yeah.
Now from scratch.
And I can
for
show you one.
Purpose.
And I can show you one. Again, this is fairly naive, as you can see, because we can connect to a database. Simply create a select that asserts whether there are data coming from this select or not. Okay, this is very, very naive. You can devise your own testing strategies for this, but the basic point here is that this select crashes when customer number is not available. So it's kind of interface testing your database. Okay, because if this select returns some kind of data or doesn't fail, I can rest assured that both of these fields are available. Okay.
Basically, is my data model still alive in the database? Think about a sort of, pardon me, a unit test for database. For my database, the point is that the application does not own the database anymore. So when you modify the database, you have to be sure by importing the tests coming from the different application that you are not breaking low-level data model for the applications. Because the database becomes another application inside the landscape of things running and moving constantly, independently. Okay. These tests are not enough. You have to perform end-to-end testing in the integration pipeline, because this does not ensure that the application logic is still okay when you change the database. But the point is fail fast, and I have to anticipate failures driven by modification to the database.
Okay, thank you.
Okay.
How much time does it take to test a contract in your pipe?
Well, it actually depends on the test, because if the test is that, if this order of complexity, well, actually milliseconds, I think, obviously. But this is a good point, because if you want to create a very large set of contract tests, and you rely on a data set that, at least for size, is comparable to what you have in production, that can end up having a huge impact on the time you spend on your delivery, on your build and delivery pipelines. And this is another reason why you have to carefully decide what to version and what to apply to migrations as test data.
As I understand, we should use contract tests because they go faster than integration.
Yeah.
All of acceptance tests.
Yeah.
Yes.
Okay.
Yeah. And this is because if I were to push that, I could be perfectly able to catch that kind of modification I showed you before, so the removal of a column, in the integration tests of the application. But when I run that in, when I perceive I broke something in application, in integration tests or acceptance test of application N, it could be way too late, because the application, that change could have happened in the, for instance, in the test environment or in the acceptance test environment, also breaking other applications. So the idea here is that you should anticipate as much as you can your testing, so that those changes are prevented to go in any of the environments from production down to your integration environment, if they are not allowed to do so. Okay.
Every code change, yes, every database migration is tested against a new version and previous version in your project, because you need to, based on what you show us, yes, you also need to, you said that your blue and green containers need to work with database, yes. So do you test your integration against these versions of application?
No, this is done in the integration pipeline. I mean, during development, you don't have to care about these kind of problems if you perform backward compatible changes. So we are not testing. Yes, to be sure, no, we are not doing this, because usually you find out these kind of problems if you don't put any rule. I mean, it will happen that an application is in version 1.1 or 1.2, and the other one in another environment is slightly behind. So you don't need this kind of complication. But one caveat: we are still seeing how this model fits in our customers. It seems to work. It fits to our. The first results are promising. We have dealt with lots of issues, but we have to iron out something more, maybe. Okay.
Okay. One question. You've told us a lot about structure migration, but what about data migration itself? What strategies do you use to achieve zero downtime on huge databases?
It's okay.
That's another open point, because when you want to migrate large amounts of data and you want to apply migrations on top of those data, you probably end up having a fairly large amount of time spent on those migrations. Okay. This was not part of this talk, but you can devise some strategies to you can clone your database and have multiple copies of your database and reuse a blue-green deployment strategy for the database. Okay, that opens up another whole host of problems in terms of synchronization between the two and transactionality. Okay, it really is cost effective to take data into account when you migrate your database, and you want to apply data migrations automatically. This is why you always end up having to resort to some sort of pattern to do that. And you should always try to apply your database changes, even on large databases, following patterns that, for example, in the expand and contract pattern, allow you to adjust your database in a rolling way. Okay, so you apply migrations. For instance, you clone a column, you adapt the content of this column while you're still accessing the first column. Okay, so you can apply migrations to new columns, to new version, to new structures, and then switch to the new structures when the old structures, when the new structures are aligned. Okay, that could be a pattern to use. So again, green-blue deployment and expand and contract can be reused also for data migrations. But again, data migrations have a host of different problems.
Thanks.
It's up to you to put in place application logic or deployment logic in order to solve your problem. I mean, if you have 50 gigs of data, it will take you some amount of time to apply the migration, and you have issues with the data that's updated by the application in the meantime. So it depends on the migration you have to put in place. Fortunately, that's a problem for our database managers, not for us. We are dealing with application. Anyway, you have to find out a strategy based on those patterns, but with some clever. It depends. Sometimes you have sharding and batch copying, and then a mix of application logic and database updates made in batch, or because it depends on the kind of database. If you have online data, you cannot run a very fast batch because you screw up the performance of the online transaction. It depends on the problem you have to face, on the migration you have to face. So it's difficult to find a pattern or a
Maybe last question. How are you doing the migration using the migration when you have replication, right? So you have one database, but for, let's say, in case of failover, you have the second one, replication. And how you deploy in the production when you have two databases, replication, right? So you put into first, blue-green deployment, on the second, in parallel, replicate the database.
It's something that never happened to me. I cannot.
You know, the simple case, you have the database, gigabyte, terabyte of data. But for first case scenario, you have a second database. If the first will crash, you
usually have a binary log and they
Yeah. Yes.
So once
It's
you
hidden
apply
for.
the stuff on the main one, it goes automatically to the second one.
No, you cannot, apply, let's say, DDL,
It depends on the technology of the database you have. No, it's he is not wrong in asking this question. I will answer. I take care of the application, not the database. Anyway, we can ask the data experts about this.
I assume that you have, a super answer right now, but if you have experience on that.
Okay.
No, direct experience not. Usually these problems are solved by the database guys, and it's something under the hood for us. Well, and if they have a problem, they share it with us, and we can try to find some sort of application level arrangement to this kind of problems, because it depends even on the bandwidth. Even if you have, you can put in a bin log with some technology the replication of a DDL. It depends on the amount of data you have to transfer. It depends on the time. Sometimes we faced problems such as, okay, if we have to have a rollback, then we have a downtime, but we don't have time in the weekend to roll back because on Monday the system is up, but on Monday it has to be up with the modification applied or rolled back, and you end up with some sort of things. In some cases, you cannot even think about rollbacking.